Let's find the GCF and the LCM of 6 and 8. So one technique to find the GCF and LCM is to write the numbers and then draw like a huge L. Find a number that fits into both 6 and 8. We'll just choose 2. 2 fits into 6 and 8. 2 times what is 6? We'll say 3. 2 times what is 8? We'll say 4. So can we think of any other factor that fits into 3 and 4? No. So we're done. We found the GCF, which is on the left here. So we'll say the GCF is 2. And to find the LCM, assuming that we have no more factors to pull out, the LCM is all these numbers multiplied. So it's going to be 2 times 3 times 4. LCM is 12 times 2 is 24. And we can go to Wolfram Alpha to verify our answers. What is the GCF of 6 and 8? The greatest common factor is 2. So our answer is correct. Let's type in the LCM. The least common multiple of 6 and 8. It is 24 over here. So our answer is correct. So now let's try 3 numbers, 8, 12, and 20. So we write the numbers down, 8, 12, and 20. You draw a big L and pick a number to pull out. We could pick a 4, but just for the sake of the process to understand how things work, we'll pull out a 2. So 2 times what is 8? It's 4. 2 times 6 is 12, and 2 times 10 is 20. As you can see, we have another factor to pull out, so we draw another L. What fits into these numbers? We'll pull out a 2. 2 times 2 is 4, 2 times 3 is 6, 2 times 5 is 10. Now here's the thing. We can't find another factor to pull out of all 3 numbers. So this here is your GCF. You must be able to pull out a factor for all the numbers to continue on in terms of the GCF, but we've done all that we can. So we're going to multiply 2 times 2. So the GCF is 4. Now the LCM is a bit more tricky. To calculate the LCM, you have to ask yourself, can you keep going on and pull out at least another number, even with any 2 factors? And these are all prime numbers, we're done. So the LCM is going to be all these numbers multiplied all the way up here. So the LCM is 4 times 2 is 8. 8 times 3 is 24. Times 5 is 120. So we have the LCM of 120. You can verify that this answer is correct on Wolfram Alpha. Let's move on to this larger number, 15, 20, and 40. So let's use the same technique, 15, 20, and 40. What fits into all 3 numbers? Let's try 5. 5 times 3 is 15. 5 times 4 is 20. 5 times what is 8 is 40. 5, 8, 40. So what number fits into all 3 numbers? You can't. You can't pull out 2, you can't pull out a 3. So indeed we're done in terms of the GCF. So for these 3 numbers, the GCF is simply 5. However, for the LCM, you need to keep on looking. Can you even find 2 numbers in which you can pull out a factor? And the 2 numbers we're going to focus on is 4 and 8. So the way we do this is the number that we can't pull out, we simply drop it. So we're going to pull out a 4. You simply drop the 3. 4 times what is 4? We'll pull out a 1. 4 times 1 is 4. 4 times 2 is 8. So we're pulling out a 4 because you can pull out a factor out of these two numbers. But this number, you simply drop it. And because we use this strange dropping technique, we don't include the 4 as part of the GCF. But now we can find the LCM. Because 3, 1, and 2 are all prime numbers, we have this big L to find the LCM. So we have 20, 5 times 4 is 20, times 6, which is 120. So the LCM should be 120. And indeed, this is correct on Wolfram Alpha. Result is 120. And the GCF is 5.